Hi, welcome to another teardown video. What I have here is a smart UF-55 smartboard projector. This projector had been in use for thousands of hours and its lamp had exceeded its rated lifespan. It is a DLP projector using a digital micromirror chip, and also like many old DLP projectors, a lot of those micromirrors are stuck, so the image quality became rather poor. Typically, we can change the DLP chip inside these projectors to fix the image issue, but for an older projector like this one, especially the lamp is towards the end of its life, this does not make much economic sense. So I'm more interested in taking it apart and see what's inside this projector. By the way, unlike your typical projectors, this one is meant to be mounted on an extension arm on top of a smart screen. So that's, as you can see here, the optics is arranged in such a way that the image is projected upwards in this direction. I mean, actually when it's mounted, it should be the other way around, so it's pointing downwards. But nevertheless, it's at an angle. Another interesting thing is that this projector is meant to be operated remotely via either a computer or remote control only, and thus does not have buttons built in that you can turn it on and off. Anyway, let's begin the disassembling process. And as you can see, there's really not too much outside. The outside is pretty plain. It really doesn't have any connectors or things like that. So the first thing is, this side actually comes right off. When it's mounted, the power cord is plugged in here, and the whole thing is tucked away under this cover. So here are our connectors, and we have an Ethernet port and some VGA output and input. And have a standard control serial port. So it's quite standard. And here we have a compartment on top of this unit. I think that's where the lamp sits. So if we open this up, we should be able to lift. Actually, we probably need to unscrew these mounting screws, and then we should be able to take the lamp unit out. So let me do that. Okay, so now I just loosen the screws. I should be able to pull it right out. And because this unit has been operating under very high temperature, that's what all those projectors, its operating environment is like, the plastic actually becomes quite brittle. And just when I was pulling this out, actually I noticed a piece flew off, and some of these are really, really brittle, and if you touch it, it actually just falls right apart. So this is something that is very interesting to see, and actually a lot of the older plastics all exhibit the same behavior. And here's our lamp unit. So as you can see, the optics here, and this is typically a mercury discharge lamp, and it uses a high voltage temporarily to strike the anode and cathode to light it up, and then it sustains the sustaining voltage is a lower voltage, and but providing extremely high current. So these lamps are pretty expensive if you have to replace it. But as you can see, that the side actually has a mesh screen, so to let the airflow inside to cool the lamp when it's in operating condition. And while I was looking at this unit outside, I didn't see many screws, so I'm thinking that I have to remove these screws to pull this out before I can take this unit apart. And as you can see, there are some holes at the bottom, so I think I might need to remove the screws there. But other than that, there's no other screws I can see. So let me work on that, and we will come back. Okay, so I managed to take the front cover off, and this piece of lens used to sit right here. So now I think after I removed all those screws, I can take this off. By the way, so this lens actually is for focusing adjustment only. As you can see that when I move this ring, this front unit goes back and forth. It's not front unit, this front portion goes back and forth. It's a little bit hard to see, but that's what that lens is for. Okay, so now let me move this aside rather, and we can see the inside of this unit. And here is our LED, so we can disconnect this cable. And this cable is for the remote screen at the back. So as you can see here, we have a IR sensor right in this window. So let's move that out of the way. And here's the top of the shielding covering the circuit board. And in order to see anything, we have to remove all the screws here to take this shielding piece off the cover. And let me do that, and we'll see what's inside. And now we can see the main board of the projector. So let's take a closer look at what we see here. And the first thing you see is this big chip. That's I think it's a TI customized DLP chip. It might even be an FPGA, given that you can see the switching power supply here. So this would be a multi-voltage output power supply circuitry to possibly supply the voltage needed by these custom either a PLD or FPGA chip. And let's look up here. We can see this is the flash memory or SDRAM, depends on what it is, for this main chip. And here we see a analog devices. Let me focus here. It's 8099A3A. So that's a high-speed analog digital converter for the color processing. And further down here we see another chip. It's a TVP5147M. So I believe that's the one for color processing as well. And so that's pretty much on top here. And we do see this is it's a microchip PIC controller. And actually, I'm not sure if you can see the traces, but the traces here comes right to this 6-pin programming header. 1, 2, 5, 3, 4, 5. Oh, sorry, 5-pin programming header. So that's pretty much everything we can see on top of the unit. So in order to see more, we have to take it further down. I can already see the power supply tucked underneath here, but can't see too much. And I suspect there's some more stuff underneath. And so let's take a look. Okay, to get this main board out is actually quite involved. I had to take the side off, so the side panel off. So now actually the whole thing comes out in one unit. So we have a crimped earth terminal back down here, and this is the main main supply. So let's disconnect this one so that we can see the boards in a little bit more detail. And let's do that. Okay. So now we have this board out, and as you can see, there's a connector here. I'm not sure if it's for expansion or something like that, but that's not connected to anything down there. So there's a separate board here for the auxiliary IOs, and this board, interestingly, has another board attached down here. And if we take a look here, that's a Realtek chip. So this is actually for the Ethernet control. Okay, so that's a separate chip. So let's take everything apart a little further, and so it will be easier to see. Okay, so now I have removed the front panel, and the arrangement of these boards are actually quite elaborate. As you can see, that these two boards are actually connected via this board-to-board connector here. and this tiny Ethernet board, which is separate from the rest of the circuit. It makes sense because this is a building block of the circuit. They didn't have to spin the board themselves, so they just purchased from somebody else and then it mounted right here. So yep, this board, hang on, if I can just let it focus. Let me just zoom it out a little bit. So this board actually is the Ethernet controller, and it's connected right here. So on the back of this board, it doesn't have much except for this SDRAM chip and some connectors. And everything we had seen is on the other side of the board. So again, let's just take another look at the board. So what is interesting remaining is that we will still need to find that DLP chip and on that on the projector. And but here is what is inside we can see so far, and we can see that it is still tucked down. Is that switching power supply, which we're going to be taking it out momentarily. And here's some of the optics of this projector. Oh, by the way, once I made a mistake a minute ago. I said when that board-to-board connector we saw here was not connected to anything. Actually, that was not true. It's connected right here at this board. And actually, the power supply boards are actually two boards. There's this one is the one for the lamp. Let's take this out so we can take a look at it better. And it's actually covered in this case to prevent it from touching anything else. Okay, so that's this is the board for the lamp. And again, it has some riser board here. This is a DC to DC converter, and as you can see, it's isolated. So okay, so let's take a look at the main switching power supply. And so we probably have to remove this, and I can already see that the DLP chip is right underneath this one. So let's not take that out first. Let's take off. Let's take the power supply off first. And most of the projectors, it's really compact inside, and you know, if you ever need to reassemble these boards, you really need to make sure that you take notes on where things are and how it was put together, because otherwise it's just going to become a mess. It's going to be impossible for you to put it back if you somehow forgot what is the right order. Okay, so now this board should be freed right here. Oh, by the way, I'm not sure if you can see this, but there's a safety interlock switch here. So this one, hang on, let me just move this out first. So here we have this momentary switch. So basically, if the lid is open, you won't be able to power this unit on because of this switch right here. So now here is our switching power supply, and as you can see, it's actually the build quality is rather nice. It's a big bridge rectifier here, and you can see the ferrite beads on its inputs. So these are to, on its outputs rather. So these are to basically suppress the high frequency harmonics of the waveform due to switching. And there's our mains input side, and here's our isolated isolation slot. So, and here we have a Rubicon nice big cap filter here, The interesting thing is that the heatsink is right next to this power right next to this cap. But I guess given the size and limitation of this unit, you really can't do too much more about it. Anyway, so the main cap is rated at 105 degrees Celsius, so that should be plenty. It's a nice power supply board. So now what's remaining inside this projector are its optical components, and this heatsink, the unit, the chip, whatever is here, I think that's the DLP chip. So we'll take a look at that. But as also you can see here, we have a color wheel. Because of the DLP projector, every single time, every frame actually needs to have the RGB components on it. Because of the light is actually white. So what happens is it synchronizes the DLP processing with this mirror, with this color wheel, so that the actual image is a composite of different colors, and because it's happening very fast, many hundreds of times per second, so you can't see the color transition, but it's every single time is actually a grayscale image of a particular color. So which will take that wheel off soon, and we can take a deeper look. But right now, let's concentrate on removing the DLP chip. And I'm just gonna, since we're not worried about putting it back, I'm just gonna remove all the screws I can see. So let's see if we can remove this. Right now we still can't. I'm not sure. Okay, I see that there is a screw at the bottom. So unfortunately we have to remove that screw first. This is a little awkward, so I might need to remove the other components first before we actually get to that. Okay, here's the fan assembly, and here is probably I'm guessing it's probably a thermal cutoff. It's a sensor here, and okay, let's see. Oh, it seems we have another fan here. Actually, I didn't see this earlier, so let me just remove this. So this is a squirrel cage fan, and actually it has two squirrel cages. So this is probably for cooling the some components that was here. I'm guessing that's the lamp. Yeah, so this thing actually, hang on, just let me grab the lamp back. So this one actually, I'm guessing, was, you see the opening here? So this one actually feeds right into that opening, so to cool the lamp, and the air comes right out from here. Okay. So now we can see this color wheel already. Hopefully you can see. Let me just remove the excess screws. Okay. All right. So here is our color wheel. As you can see, that we have the green, and we have different colors here. So again, this wheel is synchronized with that DLP processing, and only one color is allowed to output at one time. But a combination of all the colors makes you get you a complete image of the color output. So now let's see if we can remove this unit as a whole. Okay, so after some wiggling, I finally got this piece out. So that's our main optics, and we can now, there's not much in this case anymore, so we can put this aside, and we can concentrate on this the optical piece. So now at the back end here is still, that's our DLP chip, and we still need to remove that, but now we can have a better view of this color wheel. And it's driven by this stepper motor that, you know, it's a standard bipolar stepper motor, so we can potentially use it to drive something else. So that's that. And here is our DLP chip. The mount, we still need to figure out how to take this out without damaging too much, because I do want to take a look at the actual DLP chip itself. So this one looks like, it's right here. So I reckon that if we remove these two screws, we should be able to see the chip inside. So let me do that. So this one, okay, and this is the second one. Okay, so now the chip, oh, hang on, there's too soon here. So now the chip, ta-da! So look at this. So this is our DLP chip. Now, I'm not sure if you can actually see this, but there's some imperfections you can already see. Yep, from this angle you can actually see, if you recall the screen image I showed you earlier, there's some dots here, and these are actually, it's not on top of this, but it's underneath this glass. So that is what those dots are on the screen. And via naked eyes you can't really see those stuck mirrors, but I think, you know, if you yeah, so here is a better angle, so you can see that we have some, like, you know, smear here and here. So those are the ones actually showing on the screen. Now those are things are underneath this piece of glass, so I'm not sure if it's those are on the chip or not. Probably these big spots are not on the chip. It's on this glass, so we have to take this out apart and take a look. Okay, so now we can further take this a little bit of little further apart, and if I can find the right side of the screwdriver, hang on. Oh wait, so this is actually, yep. So now that's our DLP chip. And so it doesn't seem like that's, you know, the lens actually is right underneath the lens, so you couldn't actually fix those image quality issues. The only way to do that is to change this chip. So here is our DLP chip, and we can take a closer look. And here is the driver board. Actually, here is the host board for the DLP chip, and how it was mounted is kind of a zero force insertion. So when you twist this the screw here, the space actually moves left and right, so it's kind of like you know, your CPU socket, so it locks it in place when you screw it backwards here. So now this is our heatsink for the DLP chip, and this is the remainder of this optics. So as you can see, it's quite nice, the optics, and it it does go at an angle because of the requirement of the mounting of this a smart board, and so this could potentially be very interesting. And I'm not sure what I can do with this, but I probably can take it apart. Let's take it apart. Why not? And I just took away the main optical path. Oops. Here, sorry about that. So basically, as you can see, here is where the light exits onto that color wheel. So you want to turn the color wheel here. As you can see, that's where light is exiting, and it's basically light comes from the color. It's coming in from the color wheel rather, and not exiting, but it comes in from the color wheel and goes through these lens, and it reflects back onto the projector. So here are the lens pieces. These are nice convex lenses. Ooh, it's pretty nice. And so this can be used for other experiments. I think this is as far as I'm going to take this piece down, because there really isn't much unless you are very into optics and you can see what each of the individual lens is inside. But I will, do that off the camera, because there really isn't too much there, except this. We can adjust the focus via this little lever here. So, and then here is our color wheel, so we can probably use this for another experiment by powering this stepper motor. And by the way, here, as you see, these 4 leads coming out, that's actually from the optical encoder, so that you know which position the color wheel is at. So actually, it's this black area on this rotation surface basically tells it every rotation. So I assume that within the rotation, it's probably just calculated via the different steps of the stepper motor to know exactly at what time which color is being presented in front of the lens. So that's what's inside a smart UF-55 projector. If you like the video, please give it a big thumbs up, and I will catch up with you next time.